Hello friends, welcome to the next session on analysis of arches. So today we are going to consider a 3-inch regular parabolic arch with slant loads inclined. So let us consider this a problem. A 3-inch parabolic arch ABC is subjected to 2-point loads as shown. Let these angles be with respect to horizontal 45 degrees, 30 degrees. Let the span be let the total span be 20 meters, so it will be 10 meters for half the span. Let that rise h is equal to 4 meters. Okay, so we'll start analyzing the problem. Let VA be the vertical direction at A, H, VB, again H. Let these distances be given as 6 meters, 5 meters. Now since the loads are inclined, we need to find its reaction components, find its resolution of forces in horizontal and vertical directions, and find out. 150 is 45 degrees with respect to horizontal, so this component will be 150 cos 45. Its vertical component will be 150 sin 45. Similarly, its horizontal component will be 200 cos 30. So this will be 200 sin 30. Let this vertical distance be YD. Let this point be D. Let this point be E. And let this vertical distance be YE. So to find reactions or anything, first I need to calculate the vertical distances YD and YE. So let me start. Rise equation. Generalized rise equation is y is equal to 4h by L square x L minus x for point D. For point D, let this be point D. X distance is x is equal to 5 meters. Using rise equation, I will calculate this YD, vertical distance YD. So YD is equal to 4 into rise h is 4 meters divided by span L, total L 20 square, into x is 5, L total span is 20 minus x distance 5 meters. Substituting all the values, you get YD is equal to 3 meters. Next come for point E. For point E, so this is point E. Horizontal distance x is 6 meters. Vertical elevation is YE. Total span L is 20. Rise h is 4. So let us write the equation. For x is equal to 6. YE is equal to 4 into 4 divided by 20 square into x distance is 6. L minus x, L minus 6. So solving this, you get YE is equal to 3.36 meters. Now let me find the reactions first. Summation of moments about A is equal to 0. summation of moments about A is equal to 0. Again same, clockwise forces are positive. Now here let me start from this, start from B, come towards A. So here let that first force be VB. So I will be writing those equations here. Sign for VB will be minus VB into perpendicular distance of VB from A 20. H does not come into picture. Come to this horizontal component 200 cos 30. Sign will be minus 200 cos 30. Perpendicular distance will be YE. Come to the vertical component 200 sin 30. Sin will be plus 200 sin 30. Its perpendicular distance from A, from here till here. So from here to here this is 4, from here to here this is 10. So perpendicular distance is 14. Now come to these forces 150. First let me consider 150 cos 30. Sin will be plus 150 cos 45. Perpendicular distance will be YD into YD. Come to next force 150 sin 45. Its perpendicular distance is 5 plus 150 sin 45 into 5 is equal to 0. Solving this you get VB is equal to 83.32 kilonewtons. Okay, now let's write equation for moments about B is equal to 0. Summation of moments about B is equal to 0. Again same, clockwise moments will be considered positive. Keep your finger at B. Start analyzing from A. Consider all the forces from A till point B. So let us start writing that equation. First consider VA. VA into perpendicular distance is 20. Now consider 150 cos 45. So sign for that will be positive plus 150 cos 45 degrees. Perpendicular distance is YD into YD. Now come to this force 150 sin 45. So that will be minus 150 sin 45. Perpendicular distance from point D to B. So from here to here this is 5, this is 10. 15 minus 200 sin 30 into perpendicular distance is 6 minus 200 cos 30, perpendicular distance is YE is equal to 0. So solving this I get VA is equal to 122.73 kilo newtons. Now let me write moments about C is equal to 0. Consider RHS portion. Moments about C from here till C. So start minus VB into 10 plus H into perpendicular distance is 4 plus 200 sin 30 into perpendicular distance from here till here is 4 plus, consider this force, 200 cos 30. Its perpendicular distance, just look at the things here, its perpendicular distance is this much and this is given by 4 minus 3.36 is equal to 0. So solving this, you get H is equal to 80.59. Now let me write bending moment equations. Moment at A is equal to 0, at B is equal to 0, at C is equal to 0. Moment at D, start from A, go till D. 1, 2, these two forces we have to consider. So moment at D, MD is equal to VA into phi minus H into YD. VA into 5 minus H into YD. So I get the value 371.88. Similarly, moment at E, consider from C till E. I have to consider VB and H. VB into 6 minus H into YE. VB into 6 minus H into YE. So I get the value 229.13 kilonewton meters. This completes the problem. Thank you.